The next unit to cover in Chapter 3 would be solving systems of equations where you have more than two variables. Like this example here, 17x minus y plus 2z equals negative 9, x plus y minus 4z equals 8, and 3x minus 2y minus 12z equals 24. So in order to solve this equation, the first thing you have to do is use elimination to get two equations with two variables. And the variables have to be the same too. So when looking at this example here, we have to figure out a variable to eliminate. You can eliminate whichever one you want, x, y, or z. Looks like here y, they're opposite of each other already, so let's eliminate y. And if you take those two equations, and you add them together, you would get 18x minus 2z equals a negative 1. Since we eliminated y from the first two equations, we now have to eliminate y a second time, either using the first equation and the third equation, or the second equation and the third equation. And so we're going to take the first one and the third one. No, we're not. We're going to do the second one and the third one. Because in order to eliminate y, I would have to multiply this equation by 2. So I will get 2x plus 2y minus 8z equals 16. The third equation is just going to stay. And now when I add those together, I will get 5x minus 20z equals 40. So now I've completed step 1. I've got it down to two equations with two unknowns. Now it is a matter of using the things that you've done before, solving two equations with two unknowns. And you can do this by elimination or substitution, and I'm going to use elimination. So in order to do that, I'm going to take this equation and multiply it by a negative 10 so I can get rid of z. So that would be a negative 180x plus 20z equals 10. Combine negative 175x equals 50. Divide by a negative 175. And x will be a negative 2/7, because you can divide the top and the bottom by 25. Now that I know what x is, I can substitute that into one of these two equations to come up with what z is. I think I will use this one. 18 times a negative 2/7 minus 2z equals negative 1. 18 times a negative 2/7 is a negative 36/7 minus 2z equals negative 1. So now we have to add 36/7 and negative 2z equals, and that's negative 7/7, so it would be 29/7. And then when you divide by a negative 2, z will be a negative 29/14. Now that we know that z is negative 29 over 14 and x is a negative 2 over 7, we can go back up to any one of the original problems to figure out what y is. And we're going to use the middle equation. X, y, negative 4z, and 8. And so we can replace x with a negative 2/7 plus y minus 4 times negative 29 over 14 equals 8. And let's see, 2 goes into that, and that becomes a 2, and that's a 7, so a negative 2/7 plus y plus 58 over 7 equals 8. And when you combine this and this, you will get y plus 8 equals 8, because 58 minus 2 is 56, divided by 7 is 8. Subtract 8, and y will equal 0. So now we know that x is a negative 2/7, y is a negative 29 over 14. No, y is 0, and z is a negative 29 over 14. Looking at another example. Try to eliminate a variable. Let's see, here we have 2, 4, and 3. Here we have 3, 4, and 2. And here we have 5, 5, and 2. I think we'll try to eliminate z in this case. And the first time we're going to combine those two equations, because one's a negative 5 and the other one's a positive 5. So if we just draw our line and combine them, you would have 2x plus 7y equals 10. To eliminate z a second time, you're either going to have to combine first and third or second and third. And let's see, in order to do, let's go second and third. Multiply this one by 5 and that one by 2. So we would have 8x plus 8y plus 10z equals negative 30. And here we would have 15x plus 10y minus 10z equals a negative 280. Combine those, and now you have 23x plus 80y equals a negative 310. So you have this equation and this one. And now we have to try to eliminate another variable. Let's try to eliminate the... Let's go with the y's. We'd have to multiply this one by 80, this one by a negative 7. So let's see, 160x plus 560y equals 800. And that's going to be a negative 161x minus 560y equals a positive 2170. And so now we get draw our line and add that together. That'd be a negative x equals 2,970. What the heck? All right, something was definitely wrong as I was going too quickly. And that's back here, right there, which I'm sure most of you saw as I was going through this, because when you add 8 and 10, you do not get 80. You only get 18. So that renders all of this just a waste of time. So let's go back and correct that. Now, if we want to get rid of the y's or the x's, let's see, we would multiply this one by a -7 and this one by 18. Let's try that now. 36x plus 126y equals 180. And then we'd have a -161x minus 126y equals 2170. Draw our line and combine, and let's try adding this time. So that would be a -125x equals 2,350. Now we can solve for x by dividing by a -125. And when you take 2350 divided by a -125, divided by a -125, you get x is equal to a -18.8. And it's a decimal, but it's an ending decimal, so we can leave it like that, or you could say a -18 4/5 if you wanted to do that as well. So now that we know what x is, we can use that to substitute it into either this equation or this equation. And let's see, I think that has smaller coefficients, so we're going to that one. So we have 2 times -18.8 plus 7y equals 10. And multiply that, and it's a -37.6 plus 7y equals 10. And then you would subtract or add 37.6. To get 7y is equal to 47.6. And when you divide that out, y will equal 6.8. So now we know what x is. It's -18.8. Y is 6.8. And we can go back up to one of the original problems to solve for z. We're going to take the bottom one. 3x plus 2y minus 2z equals a -56. X is a -18.8, so 3 times a -18.8 plus y, which is 6.8, 2 times 6.8 minus 2z equals a -56. Well, 18.8 times 3 is 56.4 of the negative variety, plus 13.6 minus 2z equals a negative 56. So then we can add 56.4 and subtract 13.6. And we will have a negative 2z equals negative 13.2. Then finally divide by a negative 2, and z will equal 6.6. And that means that x is a negative 8.8, y is 6.8, and z is 6.6. And that's how you solve equations with 3 variables. One other thing about these equations, if you get to a point in the equation when you're solving and you have something along the lines of, say, 70 equals 24, no variables anymore, that is not a true statement, so therefore there would be no solution. If at some point in time you get something along the lines of 15 equals 15 and you've lost all your variable, this is a true statement, so there are infinite solutions. So now you can work on the assignment that is given to you.